hosting the JeffSolves MedTech Med Device Incubator pitches for 2021. There's 4 great teams tonight that'll be presenting the work. Again, I'm here as a representative of Bresslergroup. With me, helping out with this project was Pat Brandon, Jeremy Ridley, Justin Beckstein, and Tricia Eckert. So it was a real team effort from Bresslergroup. It's been a great experience for us and the team here. This is a project we've been a part of for the past 3 years, one that we always look forward to doing, and we really enjoy the interaction and the energy that the students bring. So we're very happy to be part of the pitch night tonight, and looking forward to the work that the students are going to share and show with everybody. I think we're
all right.
should I talk longer?
No, yeah. Okay. Are you done?
Yeah.
Okay, cool.
Yeah.
All right.
Keep short, sweet.
Sweet. All right. Well, thanks for joining. We have an amazing group of 4 teams of new medical devices and products that they have developed around the neurology rehab space. We have groups of industrial design and medical students. So can't wait to hear their presentations. But they had a big challenge. It was around how can they design a medical device or product that improves the lives of people in this space. And so part of their design journey was understanding the problem. And in order to be able to do this, they co-designed with patients. So we're grateful for an organization called Patient Savvy that connected us with patients in this space, and that they were able to really understand problems from the patient's perspective. And we had a lot of great faculty, both at Thomas Jefferson University from the medical school and also for our East Falls campus. They helped guide these teams, especially grateful for Todd Corlett and Eric Schneider from the East Falls campus. And then we are grateful for the innovation pillar for Dr. Heather Rose and Dr. Rose Ritz, who's helped us think about, are these products marketable, or, thinking about, how can these products be actually developed? So grateful for them. And for Bresslergroup, of course, we're here live in person, and really excited for this continued collaboration with this amazing company right here in Philadelphia. I want to kick it off to Dr. Tikaczynski. He is the provost of Thomas Jefferson University and the dean of Sidney Kimmel Medical College. So he's joining us virtually online, and he is a real thought leader and visionary in this space of rethinking medical education, rethinking the future of what healthcare should look like. So Dr. Tikaczynski is going to say a few remarks. So we're going to invite you now to speak, Mark.
Okay, am I audio? Can you hear me?
Yep, you're good, Mark.
Oh, great. Okay, sounds cool. So I'll keep this really short. A number of years ago, you and I had a vision, which was to fuse medicine with design thinking, and it's really taken off. And by now, this event and this activity is really a part of the core fabric of our university. We started this off in the medical college, and then in 2017 came the merger with Philadelphia University, and suddenly we had this wealth of design arts, industrial design, textiles, architecture, and we've really taken it, and gone to another level. For us, this is a major differentiator for this medical college and for this university. And I think it really is something that I'm incredibly proud of. I talk about this wherever I go around the world these days, as do you, Bon. And there's just a lot of, attention and respect given to what we're doing here. The idea is to train people to think across disciplines, human-centered thinking, ready for the mid-21st century. And this is a core part of what we're doing in our educational system. So I'm really looking forward to our conversations, and thanks to the Bressler Group for your contributions and working with us on this project.
All right, thank you, Dr. Tikaczynski. And we're going to invite our first student team to come up, Team Compono. So they tackled the problem of cervical collars when people have neck injuries. So this was just a really exciting problem space. Y'all could come up and I'm gonna put on their presentation. So they worked hard in really understanding this problem of current cervical collars. So anyone who's had a neck injury, neck pain, and had to wear one of these collars, you will appreciate the work that they have done in this space.
Okay, hi everybody. My name is Emily Marshall and I'm a second-year medical student.
And I'm Jennifer Hegline. I'm an industrial design student.
And as Vaughn just said, we worked this summer on redesigning the cervical collar. We were part of a team of 4 this past summer, so 2 med students, 2 industrial design students. So this is our team here. And just to start off with a little bit of background. So most people, when they hear the term cervical collars, they probably think of it in the context of trauma or a neck injury, having to stabilize your head and neck in the case of injury. And that is a use of cervical collars. But in this project this summer, we focused more on neuromuscular diseases and connective tissue disorders. These patients, they experience neck muscle weakness on the long term. So they're wearing these collars almost every day. So they are really impacted by the design, and that's the population that we really wanted to target. And just to go into a little bit more detail about these conditions, in conditions like ALS and other neuromuscular diseases, something called dropped head syndrome can occur. And this is basically just weakness of the neck muscles, and it makes it difficult for people to hold up their head straight. You can see it's difficult for this patient here to hold her head up, and she gets sore throughout the day. So that's one of the conditions that we kind of wanted to address. And then on the other side, there's a term called craniocervical instability. This is seen in a lot of the connective tissue disorders where there's damage to the supportive structures of the neck. So in both of these cases, these patients require support from a lot of times a cervical collar on a day-to-day basis. So those 3 conditions that I kind of mentioned are the big ones that we were targeting: ALS myasthenia gravis, which is an autoimmune condition, and then hypermobile EDS, which is a connective tissue disorder. And you can see they're very prevalent diseases in the US. And we have below the estimated percentage of those patients that require a cervical collar at some point in their disease progression. So we estimated that up to 20,000 people are currently using these collars for these diseases right now. So that impact is really exciting for us. So the first thing we kind of did when starting this project was looking at what's on the market, and there are quite a few collars out there. So just learning about these different collars and what are the issues and what's missing. So on one side of the spectrum, there's kind of these intense, very supportive, very structured medical grade collars. And these are the ones that you think of when there's a trauma, a neck injury. This is what they're using in the ED to first put on the patient. So these are usually intended to immobilize the cervical spine, prevent further injury. And then on the other side of the spectrum, there's these kind of more open, less supportive collars that can be purchased online by patients. And these are just for everyday use, intermittent support. So this is kind of the area that we wanted to target more so, since medical collars really serve an important purpose in stabilizing the spine. So as you can see, there are a lot of options here. This is kind of the full spectrum. So why did we choose this market to kind of enter with another collar? We realized that for our specific patient population, ALS and EDS patients, they require a good amount of support to keep their head up, but they don't need to be totally immobilized, and they can still move their head safely. So they want to have some of that mobility to still have some control in their life. So we found that there was kind of this gap here in the middle between these collars for immobilization and then these less supportive collars that are just for intermittent neck pain or support. And that's where we wanted to come into the market there. So our approach, we started with kind of trying to understand what are the problems with these collars that are out there. And I put or problems because we found that by talking to patients, there are so many different things that are problematic about these collars. So we gathered patient input mainly through Facebook groups. We distributed a survey to patients and their caregivers as well as their providers. And then we did a cooperation with Savvy to do some patient interviews, and then just looking at Amazon reviews for those collars that you can purchase online. And from this, we found that there are really a lot of issues with these collars, from most common to least common, from left to right here. Basically, the biggest takeaways we found from this was that these collars come in standard sizes and there's not a lot of adjustable features. So patients oftentimes can't fit the collar to their unique neck or face and also to their unique support needs. So a lot of our patients end up buying multiple collars, using different ones for different activities. And this, as you can imagine, gets very expensive and very tedious. We just want them to have one collar that works for them instead of having to go out there and figure out all these options. So from all those problem areas, we wanted to narrow it down to something that we could really design well in a collar. And you can see from these patient quotes, something that really stood out to us was that for patients with ALS and EDS, as I'm sure a lot of people know about these diseases, there's a lot of loss of control and independence. And we found that these collars were almost like adding to that when they're supposed to be a solution for these patients. And that really bothered us because when do these patients get to have some control and some comfort in their life? So we found that they were taking the collar off for activities. It was harder to do activities with it on. They felt very restricted in the more intense collars. So basically, we found that these collars were kind of taking away elements of independence and ability to do activities rather than helping our patients. So this is where we wanted to focus. And this is one of our patients that we met at this point in our design process. His name is Ron. He has bulbar type ALS. He was diagnosed last year, and he's wearing one of the collars there, one of the less supportive ones, as you can see. And he uses them all day, every day. But in talking to Ron, something that stood out to us was that he could use the collar all the time, but because it makes it a lot of things more difficult, he actually takes the collar off for a lot of things or makes his own adjustments, but then the collars end up breaking. So it really wasn't working for him. And here you can see him eating. This was one thing he told us about. He takes the collar off for eating because it just wasn't enjoyable with the collar on. He was worried about swallowing. And so instead he holds his head up so he can look at his food and bring the fork closer to his mouth. So this was something that really gave us kind of like an aha moment of maybe we can make that motion easier with the collar on. And there's a lot of different activities you can imagine where you need to look down.
So I will be talking about our design process and designing our solution and how we got there. So we really wanted to make sure we had an in-depth understanding of our problem space, the pain points, and most importantly, an understanding of our users. To get to our problem statement, our early design process included different types of research methods and synthesis. To get a first-hand experience, we wore different types of collars commonly used with patients with ALS. We wore them while we were sitting and doing our research, while we were around the house doing chores, or when we were out running errands. This step helped us gain important insights about our patients' day-to-day lives. As Emily previously mentioned, we conducted patient and provider interviews. With each iteration of this cycle, our questions and our patient demographics grew more and more precise. So next, we synthesized our research by finding connections and building themes through affinity mapping, empathy mapping, and creating user personas. So then we visualized possible ideas and directions through concept sketches. We cycled through this process a couple of times until we found the exact problem we needed to be solving, and once we knew it was the right problem to solve. So this brings us to our problem statement. How might we create a cervical collar that allows for increased control and flexibility during various daily activities while still providing patients with sufficient head support? So our research indicated that the lack of adjustability was the main cause for most of our patients' pain points. There are many potential areas for adjustment on a cervical collar, as you can see, but after conversations with our patients like Ron, it led us to focus on a pivoting jaw piece that would be the best to have. So advantage of pivoting jaw pieces, the movement provides patients with safer head movements, accounts for the variability in sizes of the head and neck, and most importantly, it gives them the control to adjust their focus for different activities, such as eating. So we set some parameters for our design goals. The patient's neck needs to be supported throughout the entire process of adjustment. If not, when the jaw piece drops, so will the patient's head. And this needs to be a product that is safe and helpful for our patients to use. We also want the collar to be aesthetically pleasing, but we also have to keep in mind that our patients have limited manual dexterity. So a solution that is too small and too hard to use is not a good solution at all. It also has to be easily accessible by both the patient and their caregiver. And then lastly, the shape and materials of it, especially with conditions like ALS, a lot of our patients have muscle atrophy in the neck and clavicle area, and also some of them may lose feeling in those areas. So we need to make sure our collar avoids any pinching or harsh pressure points that could lead to any irritation or further cause things like ulcers. So now we have defined our problem space and research, and now we're moving on to developing and testing potential solutions. So initially, we used the Philadelphia collar and styrene sheets to use our research-based pivot points. Here's a video of Emily demonstrating. Then we moved on to the side support pieces, and we were finding the different positions and angles that best support this type of movement. So this is our first functional prototype. It uses the Philadelphia collar for the chin, a Miami J for the chest, and the side is styrene foam. The pivot you see on the side is actually from a welder's helmet. It still functions in a very similar way. From the video, you twist to unlock, move down to your desired angle, and twist to relock. So in this version, we intended to add a rotary damper for a more smooth and controlled look down, as well as look into some mechanical leverage for looking back up. So with this, we introduced to you compono collar. So compono is actually a Latin verb. It means to adjust, arrange, and compose. And in this graphic, you can see that this demonstrates the basic pivoting motion and how it directly correlates with the user's line of vision and what they're focusing on. So this is a graphic of our first collar. The pivot point gives the user freedom of self-adjustability. This version in the back was made from elastic and had 2 magnetic snaps. Both of them were on the same side, which gave easy access for donning and doffing. This was also to be made with a biostatic foam. So this material actually has the properties to prevent bacteria from growing. And a lot of our patients were talking about the heat that these collars collect. So it's very important that we protect the areas that are susceptible to any type of irritation or even infections. So this diagram is of our first functional prototype, how the ratchet suspension components along with the rotary damper would exist in relation to the collar. Even though we're still making iterations on the mechanism, it was still very helpful to see this and how these parts would be visualized with the collar and how much space they would take up, and definitely helped with our feedback. So in this picture here, you see me eating with the Philadelphia collar on in a very unnatural position, and it was hard, and I spilled my cereal while I was trying to do this. And then in this photo, you see me using the compono collar, looking down at a much more enjoyable and comfortable angle, but I'm still getting the support that I need. So what sets the compono collar apart? Our collar gives patients the ability to self-adjust in real time, and they're able to be present in the task at hand, and while doing it, while being supported. And all the collars on the market now don't provide this for our users, and that's why our collar is different. So our next steps, right now we are currently working with our patients and ALS providers to figure out the exact parameters we need to use and the degrees of motions that would best suit our patient population. Once we have the specifics down, we can cycle back to the exact mechanics that would work best for our requirements. For materials, since the neck is such a sensitive area, we are still continuing to prototype with different materials to make sure our collar is as sturdy and supportive as possible while still being breathable and soothing on the skin. And then lastly, we are currently working with Jefferson ALS Clinic and conducting an IRB research study, and we are very excited about that. So lastly, here's an aspirational slide with some other future developments we are looking into. Here you can see more adjustments of the height and more on the back, as well as the possibility of adding a pouch that can be cooling or heating, which adds a therapeutic element to our patients. So thank you very much. And we would like to thank all of our mentors and everyone that helped us with this project. It's a great learning experience and we really enjoyed it.
Yeah, any questions? With you?
One question from the audience is, did you assess how much more this new collar will potentially cost?
So to get the exact number for that, we really have to know exactly the materials and like the mechanism and like how, for example, like how much the degrees of motion will be. So we're still in there. I think we wanted around like the $60 mark, but there's a lot of factors that will go into that.
Yeah, and right now our goal is kind of just to work with the patients we've already met at the ALS clinic and just make them a collar for themselves to try out and see if they like it. And then we'll kind of move into maybe making more in the future and pricing it.
Another question is, have you thought about cleaning options with the foam components, given the chance of spilling food, etc.?
Yeah,
I'm a
that's a
messy eater,
That's a
so,
great question. We didn't go
have
in
a
too much into the
photo.
materials, but we worked with some Becky from, oh yeah, there you go, from Jefferson Textiles. And our idea was to have 2 fabric sleeves that can be easily, like one over the top part kind of here and one here. And they can be easily removed and just thrown in the wash. As far as the foam, we're still kind of figuring out how we would secure that to the plastic backbone and then cover it with the fabric. Because we don't want the foam to, build up too much bacteria. But hopefully the fabric would cover the foam completely so it doesn't get dirty and the fabric can be washed repeatedly.
how about you keyed in on up and down? How about side to side mobility?
We thought about side to side a lot in the beginning, or all these different motions that could be possible. But for ALS, that might be advantageous, but for like EDS patients, which was our other patient population, too much motion isn't a good thing for them, especially the side to side. So we wanted to keep it kind of in one plane. And that seemed to be the motion that was most helpful to our patients without compromising the integrity and strength of the collar. So.
But
And we
you
were
could,
talking
but you
about-
could make that, you could make that an option, the side to side, which could be clicked on or off.
One thing that's also common with ALS in this patient population is sometimes one side of the neck will atrophy at a different rate than the other. So sometimes they start to tilt this way, but that percentage of people is
Small.
very small, but that is another possibility of a plane that we could use.
Got it. And last question, if the person does not have dexterity to reach the controls themselves, have you explored about making it adjustable or, the collar?
The people that can use
No,
the,
they can't.
they have,
trouble
yeah.
with the dexterity.
So we're thinking with the dexterity, it's kind of tricky because ALS is so varied. And it does seem like a good amount of our patients might have trouble with small finger movements. That's something we definitely want to test with patients, give them a couple of different options and see what works best for their hand motions. But we also think we'll probably have to make kind of a cutoff. And if you don't have this amount of dexterity, then all of these patients basically have caregivers that could help them and easily make those adjustments, or the physician could help them as well.
Okay. All right, thanks. All right. Team Solea. And thanks, Heather Rose, sorry for not repeating the questions. We'll repeat them for the next round. Thanks for asking them. So I invite you to come on up. I love sneakers. I love Air Jordans. And so this team has thought about redesigning the sneaker for certain patients with leg limb deficiency or discrepancy. So really excited about their exploration. So
I'll get you guys set up in just a second.
Okay.
Okay. So we're not getting closed captions.
Okay, hello everyone. My name is Anusha. This is Katie and this is Zane. We're all MS2s, and we'd like to welcome you to the world of interchangeability and adaptability with regards to lift systems for footwear. Our journey begins at the playground. The heroine of our story is 8-year-old Jenny. As Jenny zooms down the slide and runs through the playground, you would never know that she has already undergone her first surgery at the young age of just 3 years old. Jenny was born with an 11-centimeter leg length discrepancy. And although she went through an arduous journey of occupational therapy, PT, and rehabilitation for that discrepancy change, as she grew, that leg length discrepancy grew as well. And she actually had to get another surgery in just this past year. Now, I want to take you back to elementary school. You're looking around at all of your friends, and everyone has different shoes. Blue shoes, green shoes, shoes that change colors, shoes that sparkle. But you're not able to change your shoes. You only have the same pair. And that's because that's the only pair that you were able to put a lift system onto. For Jenny, that's her reality. And although this isn't something that you and I think of on a daily basis, for Jenny, our admirable fashionista, that's her whole life. She's not able to express herself as fully or show everyone her personality as much as she should be able to. Hearing Jenny's story and learning from her and her mother about all of the difficulties they had in even customizing one pair of shoes to get that lift system attached led us to this field of cerebral palsy. We wanted to see if there were any other children out there who weren't able to be kids. The process of getting these shoes and attaching a lift system even to just one pair is incredibly difficult. But let's talk about what this leg length discrepancy is. For anyone who doesn't know, leg length discrepancy is a difference in the lengths of your legs such that one foot comes up much higher than the other foot. In order to adjust for the discrepancy, you attach a lift system onto that shoe for the leg that's shorter. We found that a lot of patients who have leg length discrepancies also have cerebral palsy, which is a neurogenic disorder. Going through a research paper done by the American Society of Pediatric Orthopedics, we found that with hemiplegic CP patients, which is CP that affects only one side of the body, up to 50% of patients within the age of 13 to 23 had a leg length discrepancy. Now, why is this a problem? A leg length discrepancy, if left untreated, leads to sacral and pelvic distortion. That means that any of these kids who are living with this discrepancy, who don't correct for it, are going to have mobility problems, problems with their daily lives, things that are going to impact them for the rest of their days. I'm going to pass it on to Zane to talk about next. Before I do that, we also wanted to talk a little bit about the different causes of leg length discrepancy. For Jenny, hers is a congenital condition. This is usually what happens with patients with CP as well.
Okay, so after we talked to Jenny and we did a little bit of research on our own, we decided to talk with occupational therapists. We partnered with a physician who is a pediatric physical medicine and rehabilitation physician. We joined Facebook communities for people living with CP, and we conducted patient interviews. And we did this for two reasons. We wanted to hear from the people who were treating the patients living with CP and leg length discrepancy, and we wanted to hear from the people themselves who had the leg length discrepancy and hear what their thoughts were towards the current products out on the market. And so after talking with these patients, we found 4 major pain points with the most commonly used solution, which is this permanently placed leg lift that you can see on, or shoe lift that you can see on this slide. And so one of the major pain points that people were having was the cost of these shoe lifts. So for each shoe lift, each one needs to be custom fit to the shoe and placed onto the shoe. And you need to do that for every single pair that you own. So as people were buying more pairs of shoes, the cost started to add up. And what was happening as well was that insurances were not covering the shoe lifts anymore. So people were paying out of pocket for it and it became taxing on them. Another problem was with pediatric patients. So pediatric patients would grow out of the shoes faster than they would grow out of the lift themselves. So they needed to buy a new pair of shoes because their foot length was growing, but they didn't need to change the lift up necessarily. And so even though they changed shoes, they still need to buy a new custom lift for that shoe, which costs more money. Another problem was interchangeability. So with Jenny, for example, she was able to have a lift planted onto her sneakers. And that was great for her, so she could play with her friends and classmates in recess. But when she needed to go to a more formal event, she didn't have the shoes that matched the attire for those events. And so she kind of wanted something that she could move to a more dressy shoe. And finally, aesthetics. She didn't like that it was something that made her stick out and feel like she wasn't the same as her classmates. And so taking those 4 pain points, we came up with 6 user needs that we wanted to address. We wanted to address shoe interchangeability so that you could have that versatility between wearing a sneaker versus a more dressy shoe. We wanted something that adjusts to the foot as a child's foot grows. So that way they don't need to keep buying a shoe lift over and over again when they outgrow a pair of their shoes. We wanted something that's affordable because we want many people to have access to this product. We want it to be available for as many people as possible. We want a fast turnaround time, meaning that we want something that you can take from the time that you bought it to putting it onto your shoe in a fast fashion so that you can use the product as soon as possible. We want something that's going to look aesthetically pleasing. And ultimately, we want something that's going to provide the stability and the support that patients with leg length discrepancy need. So putting that all together, we came up with our mission statement, which is making shoe lifts more accessible for pediatric patients with leg length discrepancy by increasing the longevity and adjustability of shoe lift. And so placing those things in a triangle, we can see at the top, we have our keystone, which is our mission statement. And that's our guiding point that I just discussed on the last slide. And at the base, we have the 2 pillars that are going to hold up that keystone. The first is going to be interchangeability, that adjustment between different pairs of shoes. And the second is the adjustability so that you can have the lift grow as a child's foot grows as well. And with that, I'll give it to Katie to talk about the market.
So as we've discussed, our target audience is going to be these pediatric patients with leg length discrepancy. We've focused in a little bit more on specifically patients with a gross motor functional classification system level of 1, 2, or 3, which includes patients between the age of 2 to 18 that are able to walk around. Our secondary users would be any home care helpers, which would include people like parents, siblings, other family members, or just anyone who's an important aspect of this child's life that is helping with their care, education, or just health all around. Our last population that we think would benefit from this is the healthcare industry. We feel that physicians, physical therapists, occupational therapists, as well as pedorthic and orthopedic businesses would be able to use our product to recommend, prescribe, and or sell our product to our primary users. When looking more into the market size, we actually found this is a vast problem. Just within the pediatric population in the United States, 24.3 million, or a third of the United States pediatric population, has some sort of leg length discrepancy. Focusing in more on those with cerebral palsy, 2 to 3 out of every 1,000 children have cerebral palsy. And within this population, 20 to 30% have the hemiplegic CP that Anusha talked about earlier. And a vast majority of these patients with this type of CP do have a leg length discrepancy. So there is a large market out there and a huge need for a product like this kind. Looking into the products that are currently on the market, the most popular and most highly recommended solution are these custom lifts. It has the advantage of being fitted to the patient's exact needs. However, the process of attaining these lifts is multi-step and very long. Patients must first get fitted by their doctors, buy a new pair of shoes that can actually be fitted by a cobbler, which again is limiting these patients to a certain section of shoes that they can wear to begin with. Then the cobbler has to rip apart the shoe, take off the sole, insert the lift, and reattach the sole. All in all, this process takes anywhere from 2 to 4 weeks and costs a minimum of approximately $70 for the smallest lift size. If we think about the rate at which a child's foot grows, it grows about half a size every 2 to 4 months. If we assume that feet grow slowly, a child's foot will grow 4 shoe half sizes in 1 year. Even the shortest lift edition of 1/4 inch is estimated to cost $275.96 over the course of a year, and that's purely on the cost of the shoe lift alone, excluding the cost to buy new shoes. Keep in mind that each lift is permanently attached to 1 pair of shoes, and due to this cost, these children are limited to a single pair of shoes for the entirety of those 4 months. Even with the fastest turnaround time of 2 weeks, you're still going to have a total of about 8 weeks over the year in which the child will not have properly fitting shoes at their disposal. Looking back into some other products on the market, there's the heel lift inserts, which are a cheaper alternative to the custom shoe lifts. However, many patients do not like or wear these because they have to go inside the shoe. Because they have to be fitted inside the shoe, they can only adjust up to 1 inch, which is already excluding a large portion of this population. And because they're placed inside a shoe, many people in this population have to wear a specialized brace called an AFO, which is already taking up significant amount of space in the shoe, in addition to any space that a heel lift would have to take up as well. When looking on Amazon reviews for these products, we also found that excluding the patients who have CP and need these braces, it also caused a lot of issues for those with arthritis and caused a lot of pain in their joints. Another more popular solution to the heel lifts, but again, not the best option, are these strappable shoe lifts. Many patients still complain that there's pain at the attachment point, specifically over the big toe. And they're, as you can see, not very visually appealing and make people stand out a lot in the crowd. As well as there's no specific sizing, so already they're excluding a large portion of our target audience.
So at this point, we did want to talk a little bit about our prototyping process, since we're still in the process of having gone through, as you can see, many, many different types of iterations to go through this process. We are not at the comfortable position where we're ready to share it in this space, simply because of where we are in the patentability process. But if anyone would like to talk more through the prototype itself, that we are obviously still refining to make sure that for this pediatric population that we're able to provide a safe and user-friendly product, we'd be happy to talk offline or after this event as well.
And ideally, like Anusha said, we are working towards to making this product as safe as possible. As many people probably can guess, walking is a very big part of our life, and being able to make sure that is safe is our utmost concern. So ideally, our shoe lift would look something along the lines of this. First and foremost, our most important goal is promoting stability for this population, but we wanted to have a sleek design that kind of blends into the shoe, has neutral colors so that children can still show off with any brightly colored shoe on top, but if they want that discretion, they can still have that. Ideally, we want to be able to adjust it over the course of about 3 shoe sizes. And we want to be able to have it interchanged between different shoes. So we're working on a different attachment mechanism to attach it to various shoes at this point in time. So here's our team. It's myself, Anusha, and Zane. And our faculty mentors were Dr. Bonku, BG mentors were Pat and Justin, and our clinical partner was Dr. Ashley Jaffe. We'd like to give a big special thanks to the Health Design Lab, as well as all the faculty in the design at East Falls campus, and some OTs who helped us along the way. Again, Bresslergroup, thank you for having us here today and all the help along the way. And then a big shout out to our clinical partner, Dr. Jaffe at CHOP. So with that, thank you. And does anyone have any questions?
What were some surprising insights into your problem discovery? You can repeat the question.
So the question was, what were some surprising insights into our problem discovery? I think for finding the problem, the biggest insight was just how big of a problem this is. And there's really not a lot of solutions out there for this population. Even when talking about the process in which children get fitted, a lot of time they just put cardboard underneath the child's foot, and it's not a really standardized process. It was just surprising given the large population of people who suffer from this and continue to suffer from it as they grow. So I think that.
Yeah, also just the experiences that some of these people who have had these conditions kind of go through. We've talked also to older patients who have gone through this experience as children, and just to hear them reflect on it with so much kind of sadness and regret about that being a big aspect of their childhood really fueled our journey into this field too.
Any questions from over here? we'll invite up the next. All right, the next team is Grip and Go. They took on the challenge of using the bathroom when there are mobility issues. So it was exciting to see their journey. They actually even brought a toilet to the lab and started prototyping multiple iterations of their device on an actual toilet. So it was an exciting process to watch. So you'll hear about their design journey and their product.
Thank you, Dr. Koo, for that introduction. Just to reiterate, our group is Grip and Go, and my name is Hannah, and I'm a second-year medical student.
I'm Emily.
And I'm Blake. I'm Sarah.
I'm Aaron.
Okay, let's begin.
Great. So we'll get started by discussing a little bit about how and why we got into the toileting space, current products that exist, and the need for a new product to be introduced to the market. So there are currently 75 million wheelchair users worldwide. And of those users, 67% report having difficulty with ADLs or activities of daily living. Also, 33% of those users require assistance from another person when performing these ADLs. So that really got us thinking, how can we best improve the day-to-day life of a wheelchair user? And ultimately, we decided that transfers to and from the wheelchair would be most effective because transfers are performed every day by these users. The problem with transfers is safety, especially falls. So our biggest concern when we think about falls is obviously injury. And these injuries can range from bruising all the way to broken bones. So it makes sense then, especially if a wheelchair user has experienced a fall, that they would develop a fear of falling. And this fear could have an adverse effect on their day-to-day life, and it can even cause hesitancy when performing a future transfer, which can then lead to more injuries. There's also a big economic component as well. In 2015, the annual cost of fall-related injuries was $50 billion. So in one study among patients with multiple sclerosis, MS, 75% of respondents reported that they had fallen in the past 6 months. And of those falls, nearly half of them resulted in an injury. Similarly, 75% of respondents reported a fear of falling, and 66% of those users stated that they limited their daily activity due to that fear.
And then in a follow-up study that included multiple sclerosis patients and patients that had suffered from spinal cord injuries, they found that 50% of that patient population had also reported falling at some point during the transfer, and that more than 50% of those accidents happened in the bathroom space, which is why we started to turn our attention to that area. And in particular, this was very important to us because we found that when we were talking to patients that toileting was a very personal kind of experience for them, and taking control over that had a lot of impact on their self-confidence and self-esteem going forward. A lot of patients seemed like very unwilling to want to go out and leave their homes if they weren't confident that they could toilet kind of on their own independently, and create a lot of anxiety for them. In particular, some of the fears they had about public space bathrooms were that they were held in very kind of tight, close corners, and that when they used bathrooms, there weren't always ADA compliant bathrooms that were available. So it might have been missing grab bars. They might have not had any wheelchair accessible bathrooms at all or things like that. or if there were grab bars, they might have been positioned in awkward spaces, or they might have been very unstable or in just areas that weren't useful really at all. Of course, given the magnitude of this problem, there are some kind of attempts to kind of resolve it and make it a little bit more accessible for wheelchair users and other mobility impaired individuals. The most common kind of solution that we see are transfer boards, which is basically exactly what it sounds like. It's just a wooden plank that someone can put under their wheelchair and then onto the toilet and then kind of scoot across as they're able. As you might imagine, that's pretty uncomfortable to have kind of your bare bottom scooting across a wooden board. In the image you kind of see off to the left, there's like a little platform that you can scoot across on a track that slides a little bit more easily, but that's still like very uncomfortable. They're not very portable at all, and it can be very rickety and unstable, which is obviously not ideal when you're trying to go to the bathroom. Another kind of solution that's more permanent and less an attempt at a portable solution are external handrails that you see very commonly. But again, those aren't kind of the best because you can't really take them with you very effectively, and still like it's very awkward to kind of use and customize to your individual specifications. And then of course, grab bars can be helpful if they're positioned very well, but you rarely have any control over those when they're not in your own home. And when they're there, they're not very stable and they're rarely kind of in the correct spot. So.
Thank you, Emily and Blake, for kind of describing the general problem space. Now I'd like to kind of focus in on some of the patients that we were able to speak to with some specific quotes of their frustrations with the lack of adequate solutions currently on the market. One patient described how they were so afraid they were going to fall. They're nervous, they're frustrated, they're anxious. When they go to these public restrooms, like Blake was mentioning, there's not the adequate grab bars for them to have a safe transfer onto the toilet. The toilet seat can also be loose. So those kind of problems really create a huge barrier for our patients. So this eventually led us to our question that we're trying to solve of how might we improve safety and sanitation during a self-transfer to the toilet. Now, before we get into our actual product, I'd like to highlight some of the goals that we have with this product. The first goal is independence. So let's increase the confidence of performing a self-transfer without the help of a caregiver. Portability, because we want patients to be able to comfortably bring this to spaces outside of their own home, so to take it on the go. Next, stabilization. Like I was mentioning before with the unstable or potential for unstable toilet seat lids or toilet portions, this can really apply some stability to that system. Ease of use, we want to make sure that this is kind of intuitive, that the patients have a general understanding already, and that mirrors how they would transfer toilet without the use of the device. And lastly, a very important component, especially for public transfers, is sanitation, improving sanitation and acknowledging that issue when designing our product.
Thank you, Hannah. Just to achieve those goals that she mentioned, we wanted to introduce our product that we've actually gotten a provisional patent submitted on as of yesterday. So that's awesome. But the product is called Grip and Go, safe, sure, secure. So I just have in my hand kind of like the current model that we have. So the Grip and Go consists of a clip that will be able to clip onto the toilet seat, and as well as a handle to grab onto. So the clip itself not only stabilizes the toilet seat onto the toilet bowl, but also gives a more sanitary grip if patients want to grip here. As well as the actual handle itself is weight bearing enough to be able to pull oneself over from a wheelchair as well, or push off from if you're trying to go back towards the wheelchair. So some key features that we really wanted to highlight in this presentation was one, an ease of use. So our handle that we have here allows the patient to be able to put their hand in and go out and up easily. It's universal, so it's been tested on about 30 different lids and 30 different toilets, as well as different signifiers that we have finger grips to indicate where patients should grab onto. So again, this is just the prototype I have in my hand from different angles. Oh, yeah. So in our design processing and prototyping, two big key elements that we had were actual physical prototyping, as well as iteration. So we went through multiple different iterations, which I'll kind of go through in this slide. So the first one we had was just a straight bumper, straight up and down, but we realized that that angle was too steep as people actually used it on the toilet. The next one was a kind of a very unique locking mechanism instead of this just one you see in my hand. And that one was a little too complicated. And then next we actually backtracked and went specifically to only a fixing curvature, which you can see without the handle, but we realized we still needed the handle. Next, we had this kind of shark fin type of scenario where it didn't allow the patients to have like full weight bearing capability. Then we just tried just a symmetrical handle, as you can see in this picture, but we found that the hand actually gets stuck in the symmetrical handle. And lastly, that kind of led us to this asymmetrical handle that we have here, which will allow the patient to move in and out. And 5 and 6, we're currently IRB testing in process. Yeah.
So in thinking about sterilization and also in stabilizing this to the seat, we decided to evaluate a series of materials that we could affix to the inside that would assist us with sterilization and also with immobilizing it on the seat so it doesn't slip around or slip away from you when you're trying to transfer. So you can see a little bit here of what we ended up going with, but we evaluated silicone, rubber, synthetic rubber, polyvinyl chlorides, and we end up going with it's a polychloroprene, or it's more commonly known as more like a neoprene without the exterior fabric on the outside. We also did a series of evaluations testing the hand grip and the upper features on the top to see if we needed a sort of flip-flop indentation that would go between your fingers to give you more security and stability when you transfer, or if we should just go with a simple strap or something that might allow your hand to remove in and out as easily as possible. We also evaluated just sort of a finger knob that would help you grip onto the edge. There were a couple of additional ideas that we evaluated too, where you could put your hand into a mitt that would protect and keep your hand clean during the whole process. And then we evaluated several others, including a foam grip that would fit right underneath the knuckle to give you a good sense of security. And you can see the pseudo grip on the far end is pretty similar to what we wound up with because it provides immobilization in both dimensions. You can't slide out laterally or horizontally from this when you're transferring. So it provides enough security to get you over onto the toilet and also make you feel safe when you're doing it. We took our prototype to Lowe's and Home Depot and tested it on every toilet seat we could find, just to make sure that the radius of the inner and outer portion of this would fit on any toilet seat that might be available to the mass population. And so far, we haven't found a toilet seat that it does not fit on. Special thanks to the people at Bresslergroup who helped us do a FEA or an assessment of the stability and the functionality of the materials, assuming that this would be produced in an ABS. They gave us a much better idea of how much force we might be able to put on it and where it's most likely to experience the most issues. And it might not be surprising that the main issues are where it joins the body that meets the toilet seat. We do have several competitive advantages over products that are available on the market now. One is the portability of our design. This is something you could slip into a bag or a backpack. It is also something that doesn't require much setup. You just take it out and you put it on the toilet and you go. That's our plan with that. We wanted to increase the safety and stability of like public restroom transfers and make the user feel confident that wherever they are, they can use the toilet. That's pretty much the goal. And this also does create a little bit more sanitized environment for them. They never have to actually touch the toilet seat because this covers the entire toilet seat.
So we just wanted to give a thank you to not only Jefferson, Bressler Group, the innovation team, but everybody who involved in helping us create this product and moving it forward in the future.
All right, a question from the audience or online?
Yeah.
Did you intend to focus on stability of the toilets moving forward, or was that just kind of that with your design?
That was, oh yeah, oh, I'm sorry. Was it intended to stabilize the toilet seat to the bowl? Yes, that was one of our intentions, because as we interviewed patients and users, one thing is that they grab onto the toilet seat, and there are a lot of times where the toilet seat is shaky and coming off of its hinges. So that's one thing that we intended to solve with this. Yes.
Two are designed to, they're good this way. You put compressive force on them, they're fine, but they don't have a whole lot of immobilization in that.
There are other materials that they use in cases, whether it's more or how does it affect material materials, how that impacts you.
So did we consider different materials and how that might impact our design? I was just repeating the question.
We have evaluated quite a few different prototypes that were really just disposable and consisted of sort of a hand grip you could place over the toilet, just over the seat, and use, and then just toss afterwards. But we didn't find that they provided a whole lot of stability. There was an increase in your sense that you were conducting it in a much cleaner way, but it didn't help us with one of our primary goals, which was to increase the stability and safety of the toilet experience. As far as the materials, we are still evaluating other materials and working on evaluating the next step as far as how we should proceed with the
Does Dr. Tikachevsky have a question?
Yeah, I was just going to ask, I mean, this is so creative, as are all the presentations. You've addressed the variability of the toilet seats, but what about the variability of the patients in terms of, you know,
So yeah, in terms of the variability of the patient, one thing that we are doing moving forward is doing an IRB study where we actually
having the.
Should I continue?
Yeah. We're sorry, you're breaking up a little bit.
Can you please repeat the question
Sure.
about the patients?
You've addressed the variability of the toilet seat. The question is the variability of the patient. So, for instance, somebody who's, you know, quite tall, or very short, you know, so you could make different configurations of your device that, you know, have different heights and, you know, different distances from the toilet seat, that sort of thing. And could you actually build in some adjustability to it?
That's definitely a great question. One answer I wanted to say is that moving forward, we're doing an IRB study with different patients. So that's hopefully just their experience with this product. So hopefully that insight can also give us understanding of how different diversity and variety of patients interact with this, so we can make changes to our design moving forward. In terms of adjustability, I don't think does anyone have anything they want to say on that specifically? We kind of wanted to make this you buy it at the store and you can use it, anyone can use it mentality, but we will definitely consider that moving forward.
We did evaluate the idea of creating a not quite bariatric, but a larger size and a smaller size. So we'd have one that would be 400 pounds-ish, and this one is for the person who weighs about 200 pounds.
Last two questions. How does this compare to competitor products, and what are the next steps?
Next steps are we're evaluating these two designs, the asymmetrical handle and the symmetrical handle, in an IRB study with patients and experts. That's next steps. In terms of how does this compare to other products? Does anyone want to? Okay.
Yeah, so when we were doing our prior art search to assess for patentability, there really wasn't anything remotely similar to this idea in the space, other than the things we kind of talked about as far as the transfer board and the handrails. Both of them were very significantly different and had like very different negatives that were pretty substantial. And there really weren't any patients that were super satisfied with either of those existing options.
All right, the next and final team is TREMIs. So what if you had a tremor and you had to do things like eat or drink a glass of water? Is there a product out there that can help you? So this team dove into this space, and we'll hear about the design journey and the product they developed.
Yeah, come over here. The mic.
All right, good afternoon, everyone. Thank you, Bresslergroup, for having us today. We're excited to be here as Team TREMIs. We're actually a full team of 5, but 2 of us aren't here in the flesh, but they're joining us online. And thank you to everybody else who's joining us virtually. So we're excited to talk to you guys today about the anti-tremor glove that we designed with customizable weight. Okay, so taking a quick look at our agenda, we're just going to start by kind of introducing you guys to who our user is and what their journey looks like living with essential tremor. We'll follow that by defining the specific challenge that we've decided to solve as a team, and we'll spend the majority of our time actually walking through our specific design process and how we came to our final solution. And then at the end, we'll take a moment to speak about the future of TREMIs. So for defining our user, as you guys have maybe picked up on by now in the past hour or so, all of us have been focusing on individuals with some form of neurologic deficit. And when we started to decide which route we wanted to take in the beginning of the summer, we thought we really wanted to have a patient-centric approach that really came from an area of familiarity. And so we decided to pick a population of individuals living with something called benign essential tremor because, at least for me personally, one of my relatives has a very severe form of this disease. And all of us actually know some people that are affected by it in some capacity. So what exactly is benign essential tremor? It's actually the most common neurological deficit in the world, and it manifests as an involuntary shaking disorder that worsens when you go to move. So typically it's worse in the hands, but it can also present in the head as well as the lower extremities and pretty much anywhere in the body. So like Bon was saying before we came up here, imagine that you're going to drink a glass of water, and as you bring that water to your mouth, you're spilling the water along the way, and the water is, getting all over the place, getting all over you. It's an incredibly frustrating disease, and it's progressive. So once you have a diagnosis, it just continues to worsen over a period of time. Typically, the onset is bimodal in distribution, affecting individuals in their 30s, and then more commonly in their 60s and later in life. And at the moment, it actually has been diagnosed in about 10 million individuals living in the United States. So when we look at the impact of essential tremor, although it may be something that you guys in the audience haven't heard of before, it's actually 8 times more common than Parkinson's disease. And due to its progressive nature as a neurologic disorder that can be very isolating, it's actually 2 times more likely to manifest as clinical depression. And even with all the statistics, I think the most surprising fact is that there's currently only 1 FDA-approved medication to treat benign essential tremor. So just taking a higher zoomed out perspective, currently there are 25 million individuals on a global scale that are diagnosed with essential tremor, but it's actually projected that about 3 times that amount are affected by it and just not yet diagnosed. So it's affecting a pretty large population. And just to kind of drive home what it looks like to live with this, we want you guys to pay attention to this gentleman as he brings this soup to his mouth and he's kind of spilling basically half the spoon on his way. And that's really something that these individuals are experiencing on a daily basis. So when we got into our process, and we'll explain this, my teammates will explain this a little bit more in a couple of minutes, but we really used our user insights and the interviews that we conducted with individuals living with essential tremor to kind of map out what their journey looks like. And we broke it out into four phases. The first phase is the onset of the tremor. So at this point in time, individuals are hearing questions like, does your hand always shake like that? Or are you anxious? And the second phase is a more extended period of time where there's a period of coping. And people who are now having tremors have to figure out how to kind of carry out their activities of daily life in a different way. The third phase is where we see ourselves as tremies fitting in with our product. And this is where they start to turn to assistive devices for additional help. So the tremor is getting worse, it's more impactful in terms of affecting their quality of life. And now they want something to kind of help mitigate that tremor. We'd like to come in here before the final step, which is medical intervention, because in the medical intervention, there's two options and both are poor. The first is that singular FDA-approved drug, propranolol, and the second is actually a very invasive brain surgery. Both of them are not totally effective in this population, and they're also not without their adverse effects. So when we take a look at what is currently out there when we were starting this process and where could we potentially fit in, we kind of see this as a split. If you look at the lower left hand of the screen, you'll see that there's really low tech, low cost options. And on the y-axis, they're not really very customizable. So it's kind of a one size fits some option. These do come in that third phase where it's an assistive device, but they're not necessarily beneficial. Then going over all the way to the right side of the screen, you'll see we have really high tech, high cost options that are customizable, but these can be upwards of $1,000 to $4,000 per device, not covered by insurance. So we identified this open space in the middle where we saw ourselves fitting in, something that could be affordable, but also customizable. So that really drove us to asking this question that kind of framed the rest of our design process, which was, how might we create a weighted device that has the adaptability to counter each patient's unique tremor, really wanting to focus on the individual. And in finding our solution, I think the thing that kind of kept us going the entire time was keeping our focus on the patient. We basically wanted to use the user's voice to kind of just put it all together and figure out what's going to be the best design that's going to benefit this population. And when we started to do this, we actually turned to Facebook groups and we kind of joined this community of individuals living with essential tremor. And there are thousands. We joined this one group that had at least 10,000 individuals who they're looking for an answer because there's no true pharmacologic intervention that helps them. And the devices that are available out there aren't really great either. So the first question we asked was, what tasks are the hardest? And what we found was that 75 individuals said carrying food was the hardest, 60 said writing was the hardest, and 51 said pouring drinks was the hardest. At this point, we were trying to figure out, should we focus on fine motor movements, gross motor movements? And what we decided was that we wanted to tackle the tremor at its source, at the hand itself. What was really helpful in this Facebook group is that the individuals living with this were sharing with us some of the solutions that they currently have kind of created on their own. And you'll see on the right-hand side of the screen that they're basically using old mittens and putting washers in the back of the mitten to basically create additional weight that they decide is perfect for them. Or in the bottom right-hand, they're using a brace with batteries. Our next question to the Facebook group was, what is the most important aspect of a product to reduce hand tremors? And by and large, on the left hand of the screen, over 50% said that the amount of weight should be customizable. And after that, they wanted the weight to be movable and they wanted the device to be affordable. So these are the things that we decided to focus on in our design process. And then taking a quick look at a competition analysis, on the left-hand side, there are a number of devices that are in a similar space as we are. But what you'll see across the board is that Tremies is the only one that fits all of these categories. It's an affordable price, less than $100. It's available over the counter. It's customizable. It's the only one that has an adjustable weighted component. And it also has a compressive factor, which anecdotally from these users is something that helps them mitigate their tremor. So I'm going to hand it over to Kayla to walk you guys through our solution process.
Okay. All right, so thank you so much for just having us here, and thanks Jenna for giving a good background about benign essential tremor. So we're excited to introduce to you TremEase. This is our final product here. So you can see at its core, it is a glove where we're adding the weights to kind of counter that tremor. On the left, you'll see kind of these areas here that we've included in the final product, which is again based off of the user feedback, with the most significant being the customizable weight. So getting into how to use our product, we wanted to make it incredibly simple to put on and to take off, knowing that our patients already have trouble with their hands and just kind of doing day-to-day things. So this schematic here is just very basic. So it's showing that you'll put the glove on, tighten it, it'll have that compression to kind of counter that weight. You'll apply the weights to the hot spots or to the areas where you really need to dampen your tremor. And based off our research, we found that the back of the hand, the wrist, and also up onto the fingers are kind of those great hot spots. And then you'll go about your day. And then when you want to take it off, you just simply can take those weights off. There's call out tabs on the glove itself to easily remove it. And then that last final step is that they are machine washable. So moving into our product demonstration, so a little bit of background. So we mentioned that we talked to these Facebook users, and a lot of them do have benign essential tremor. One person that we met with in the flesh, which was awesome, especially during COVID, was a chemistry professor who expressed that he was starting to have trouble pipetting in the lab because of his benign essential tremor. So what we're going to do is just first watch a video of him pipetting without any sort of glove. So you can kind of see here, if you focus, you can see that the pipette is shaking, and he's kind of having some trouble fitting that pipette right into that other skinny little hole. All right, so that's him without Trem Ease. And then our next video is going to be him, oh, I'm sorry. Next video? Yeah, okay. So our next video is going to be him now with the Trem Ease product on. So at this point in the video, he's actually telling me how already he feels a lot more stable, and he feels like he just has a lot more control. Just you can see how he's holding that pipette there, and it's pretty stable. And he just slides it right in pretty effortlessly and smoothly. And it was a great experience for us to see, and really just exciting to see this kind of working in real time. Okay, so now we just want to backtrack a little bit into prototype development. And as we mentioned a lot, really this product was driven through user insights and feedback, because we want this to be something that the patients actually want to use. So starting kind of in the very beginnings, the very background of Trem Ease, we explored putting weights in different locations. So you can see the first was having just this cuff around the wrist, one having like a bigger weight on the back of the hand, and then having these kind of like Kit Kat bar shapes where they can play around. And so while we were testing it, what we found was that users really liked having the weight on the wrist as well as having the weight on the back of the hand. So they kind of merged these concepts together. And so basically out of tester feedback, we got some really great insight, with probably the most important being that the cuff on the wrist wasn't enough. It just like left the hand flopping. So they really needed something on the back of the hand as well. So that included having weights moving up onto the fingers to stabilize like your thumb and index finger. Another point that Jenna had already mentioned was that compression helps. Just having a little bit of tightness helps you feel a little bit more stable. And then the other interesting insight is that these users have good and bad days, right? So if they don't have enough sleep or they're under a lot of stress, their tremor is a little bit exacerbated, in which they might want to add on more weight or play around with where they're actually putting the weight, versus when they're having a good day or they're doing an activity where they don't need as much weight, they can kind of just take it off. So this kind of brought us to our second version, or our evolution part 2, where we partnered with Jen Rocket, who's an expert in textiles, and kind of brought our vision to life. So you can see we added the call out tabs to make it really easy to put on and off. You can see we actually extended the fabric to go up onto the fingers based off of that feedback. And then also just playing around with the weight and the aspect and the look of the glove all together. And I'm going to pass it off to my colleague Joey now.
Thanks, Kayla. So just to round things out here with a little bit of the market analysis. So to begin, we wanted to get a sense of price points for a product that something similar to what we have and what's out there. After polling the International Essential Tremor Support Group, what we found is that $100 price point seems to be that sort of sticking point in terms of what's going to still get them the perception they're getting the value out of that product. So with that in mind, we wanted to take a look at the market sizing going forward. So Bloomberg estimates place the essential tremor product design market at, $141 million as of 2019, with a 5.3% projected compound annual growth rate. That leads us to about $190 million by 2025. So just bracketing that, or plus or minus 2% on either side, we can get a sense of where the market's heading 5 years down the line. So taking that and then also projecting a 10-year forecasting model for the company that will be Tremees, we come up with valuations using discounted cash flows for a baseline, upside, and downside case. And these are listed for us here. Finally, looking at break-even revenue at our entry price of $80 per unit, we're able to see that we have a break-even price at 600 units sold and beyond. So that's sort of where we're at from a market analysis standpoint. So just talking next steps now, we're going to continue to do some tweaks with our design modifications, leading to the manufacture of our product, and also concurrently having our clinical study to validate the efficacy of the Tremees glove. And that wraps it up. We do want to acknowledge everyone who's put in a ton of help to help build our product into what it is today. That includes the Bresslergroup, the Health Design Lab, and also Savvy. So thank you very much.
This is our full team, including Fletcher and Justin, who could not be here with us in person today.
A question is, how about putting weights to slip pockets as opposed to clunky exterior attachment?
Yeah, so I can answer that. We actually had, I'm sorry. The question was, how about putting weights into pockets rather than having a clunky attachment, I believe. So the answer to that is that when we started this design process, that was something we had considered, whether pockets would be an option, but the users actually said that the pockets are too difficult. We had to keep in mind, like, if you pretend that you have a tremor, it's very severe with these individuals who have it, especially in the older population when it's more progressive. If they're going to put something into a small discrete pocket on the back of the hand, they were complaining that they can't really fit it in there appropriately. So this gives them kind of more flexibility with being able to move the weights around.
A question about materiality for the glove. How about incorporating different materials and different parts?
Yeah, the question is about the material of the glove and incorporating different material into different parts. I'm not going to get into the detail of the material, but as it stands there, we do have different materials covering different aspects of the hand, and the things that we wanted to keep in mind were breathability, compression, lightweight, and the ability for it to be washed, as well as keeping kind of mesh on the areas of the hands that are a little bit more prone to sweating.
Any other questions?
So in your video with the chemistry teacher who was wearing 2 gloves, would you expect that people would wear 2 or just 1? Would they be sold with pair, or would they be sold individually? And is there any option for them being ambidextrous?
Yep. So the question was about whether the gloves would be sold as a pair, whether they can be ambidextrous in use, and whether we foresee individuals using them on only one hand or both hands at a time. I think we leave the choice up to the user, but typically this is a problem in both hands. It just depends. As I said in the beginning, this is something that worsens with movement. So if they're only likely to use one hand while they're writing, then maybe, for example, they would only put a glove on that hand for that activity. But we would sell this in a pack with 1 pair of gloves, so 1 for each hand, and then it would come with a variety of weights, 2 different types of weights. So at the moment, we don't have it so that they're ambidextrous. We have 1 left, 1 right.
All right. Well, thanks everyone for joining in person and online. People don't think that healthcare is creative. I argue that it's probably one of the most creative industries, in the sense where we need creativity in order to solve the problems, because the problems that we face in healthcare are some of the most complex problems out there. So thank you to all the students, amazing work. Thank you to our provost and dean, Dr. Mark Tikaczynski, for supporting this program, for his vision, for thinking differently about medical education and healthcare. So we appreciate you joining us this afternoon. Thank you.